So yes, this is of course Valo Fest 2020. You've probably seen quite a number of sessions so far. This next section that I'm presenting is called Design Your App for the Cloud. How and why to build an Azure static web app. Before I get into it, I do want to offer a welcome to both speakers and attendees from Australia and, of course, around the world. We acknowledge the traditional custodians of the land from which this session and, of course, other Valo Fest presentations are hosted. And we acknowledge the traditional custodians of the lands where our Australian-based attendees are located. We pay our respects to elders past, present, and emerging. A little bit about myself. There's a couple of ways to get in contact with me or to see me on various social media platforms. I guess one interesting part of this is I've recently completed my role as a cloud architect with Engage Squared, where I did quite a number of medium to large enterprise digital workplace implementations, customizations on SharePoint on the Office 365 platform. But I'm now moving to a role, in fact I start next week, as technical partner manager and product evangelist at Valo. So I look forward to that. Hopefully this session goes well and that they decide to keep me on next week. Okay, so as for the agenda for this session, I thought I'd put up a couple of points here today just to start you off to give you a feel for what we're going to discuss in this session. Of course, it's design your app for the cloud, how and why to build an Azure static web app. So to start with, I thought I'd set the context, sort of talk about the history of web app development over the past couple of decades. In fact, I've been a web developer for I was thinking about it, actually more than 2 decades now, and that scares me a little bit. But I thought I'd start off to provide a bit of context here to illustrate a convergence of technology that we've seen very recently in the cloud-based world. And what we're also seeing with a couple of example platforms is a shifting of workloads. So, should we run code on the server or should we run code on the client in the web browser? There's a shift that we're seeing now in that regard. And that's really important for cloud app development, I think. Next, I'll talk a bit about designing your app to maximize efficiency of the different tiers. And to do that, I've kind of separated out the user interface versus data access, data storage and authentication as 4 main concepts there. And I'd like to talk a little bit about why response time and latency is important for your cloud-based app and why how that influences the architecture that is implemented for Azure Static Web Apps. Towards the end, I will reference an example architecture. Now, M365 May was an online event that I helped coordinate with the M365 Melbourne team based here in Australia. And we implemented an architecture to fill a particular gap that we had with that event. So I'm going to put up on the screen what that architecture looked like and how that relates to Azure Static Web Apps. So Azure Static Web Apps was announced in MS Build towards the end of that event, towards event of the month of May. And so what we found was the architecture that we implemented for M365 May quite closely correlated to Azure Static Web Apps and what the described architecture is. So there's some parallels there to look at, but you can also see how Azure Static Web Apps is better than all of the components that we needed to build and put in place for M365 May. Hopefully that gives you an idea of what we'll cover today. So without further ado, onto the topic at hand. So what we're seeing today is a convergence of technology when it comes to cloud-based web applications. What we're seeing is a highly capable web browsing experience. So web browsers today are rich in built-in capabilities. We see a consistency of web browser capability as well. And why that's important is your developers, when they're developing their client-side code, they want to be sure that it's going to execute as expected. And to be sure of that, what's really important there is to be confident that the API that they might leverage on the browser side is actually is there and is capable. That local storage options are available, and we're now seeing with the need to support legacy browsers, and in particular I'm singling out Internet Explorer 11 there. Now that that's going away, we're now seeing that we've got confidence as web developers that the browsers we're targeting or that we want to ensure operate our web apps do so successfully. So Internet Explorer no longer being maintained by Microsoft. I mean, it's been quite some years now that it's just gone into sort of a elongated support transition phase. That's a good thing for web developers. It means that we can start to focus on what really matters, and that is the current the current most recent standards of web development. And another important factor in the dwindling need to support legacy browsers is Microsoft Edge. So Microsoft Edge, the most recent version, the most recent Chromium-derived version, has support for legacy operating systems. And we find that's really important for enterprise environments where they might have an app that's being deployed and important for their typical business operation that only works in Internet Explorer. We can have that app work in Microsoft Edge with IE mode enabled. So for everyone else, when they deploy a web app, they can use the latest. We can use Microsoft Edge's latest engine, which is Chromium based. But we can also be sure that enterprise admins have deployed an environment where they can support their legacy apps. And I think that's a really important milestone for web developers around the world. Hopefully we'll start to see less and less browser stats that show that IE 11 and IE 10 and below are in use anymore. On the topic of convergence of technology, we're also seeing on the flip side, on the cloud side, we're seeing offerings that are like for like from different providers. So I've put Azure up there, obviously, and Amazon Web Services is two examples. And in the context of this particular talk around static web apps and what that entails, two examples might be the ability to run server-side code, and in Azure's sense, that's Azure Functions. Over in Amazon Web Services, Lambda is the sort of equivalent, I guess you could say, of Azure Functions. And also on the for deploying of code, you see in Azure a storage account with static web websites enabled. And over in AWS, I think it's what's called a bucket, an S3 bucket, which enables you to store assets and code and so forth. So what we're seeing because of that convergence of technology, we're seeing providers out there offer like-for-like offerings that compete on price. And the important thing about that is that it competes on price on a consumption basis. So storage is charged at a per gigabyte price. Processing with Azure Functions, when it's consumption-based processing, is on a per gigabyte second basis. So we're seeing this very incremental consumption-based offering from cloud providers. And this is quite a lot different to the old way of hosting sites. And I'll pick on one example, WordPress. There's any number of WordPress providers out there. When you sign up for a WordPress host, you might be charged, a per month fee. It might be $5 per month, it might be $20 per month, depending on where it is, where it's located. But you basically pay that flat fee, and that might be a shared hosting service that they're offering. But you don't get charged more or less depending on how much or how little your site is used. You're simply charged for the time, the period of the month that you've got it deployed. And one other aspect of that is, in a point of comparison, I guess, is that content management system, that is WordPress. It's running all the time. It's always there and available to respond to content management queries. You want to update a web page or whatever, you can do that. The service is running, and there's an overhead, I guess, that they're trying to cover the cost of, that is built into that monthly fee. That's quite different to this consumption-based model that we're seeing out of cloud-based offerings. And I think it's an important sort of difference to consider when we're talking about new technology like Azure static web apps. And I've got to also mention, now that there's cloud-based offerings on this consumption model, that we're seeing second-tier, what I call inner-box services. So Netlify and Shopify, these are services that are offering that next tier up. They're sort of saying, okay, here's a platform for you to deploy an e-commerce solution for you. And that is built on top of the consumption-based cloud model that they can leverage to as a scaled worldwide deployment.
There's actually, Mark, interesting question. Probably, I'm not sure if you will be coming to that. How does Power Apps compare to Azure Web Apps? And I totally get the question in the sense of naming convention, that those might be considered to be similar. Anything regarding that?
Sorry, the question is Power Apps versus
how does Power Apps compare to Azure Web Apps? What's the difference?
Well, I think when you look at Azure Web Apps, you're getting more of a bare metal experience. Power Apps is sort of a product that sits and has a reasonably good user interface that you can interact with and implement your solutions on top of. Whereas Azure Static Web Apps might be, if you take a step back and you want to write your own code, you want to write your own service from scratch, you might want to implement your own APIs, that sort of thing. That's where the difference lies, I guess. So the Power Apps platform is great if you want to work inside the box, so to speak, and implement customized solutions within the what's defined by the Microsoft ecosystem. Whereas web apps, static web apps, are more in line with if you've got a implementation that is developed as a custom solution from the ground up, then that's where you might want to consider Azure Static Web Apps.
Yeah, and to elaborate that from the SharePoint and Dynamics 365 perspective, Power Apps more towards the UI paradigm. Easy way to create a UI layer on top of existing data structure, which can be in SharePoint, Dynamics 365, or the CDS, meaning SQL Server or something else. And as Mark said, Web Apps is the whole platform to do it all.
I would also suggest that the difference there would be the audience for Power Apps would definitely be enterprise customers. So typically when you interact with Power Apps, you're more likely to be part of an enterprise. You're more likely to have a Microsoft account with your organization, and there's a lot of easy built-in connectivity capability already built into the Power Apps platform. Whereas if we take a step back to Azure Static Web Apps, that might be quite a bespoke solution. It might be a startup that wants to develop their own platform for for global world domination. Who knows? So it's that kind of difference in the platform. Choose the right platform for where you want to go with, and also choose the right skill set. Right? If you've got developers with a certain skill set, then Azure Static Web Apps would be the way to go. If you've got the power user, so to speak, the people who think logically and are logically minded, but also don't want to bury themselves in the detail of which library is better than the other library to use, that's where Power Apps has got a lot of benefits. So I think that it's a good question, good comparison to make.
Really, and thanks, Mark. Really good point. From the being a citizen developer or real hardcore developer might be a good approach. So if you want to learn how to develop Power Apps, is your way to go. If you know how to develop, please do not touch Power Apps, because you will probably screw up something.
Oh, come on now. I just know too much, right? I know why that text box is not giving me the output that I'm expecting. Anyway. Okay. So again, back to the context of Azure Static Web Apps. I also wanted to talk about the context in more broad terms, and this shift we're seeing in workloads, and I'm referring to two specific industry examples. A lot of the people that might be watching this this session might be very familiar with SharePoint, and I put there as well another example, which is WordPress, which is a sort of as far as content management systems concerned, there's a lot of parallels in the development of SharePoint and the development of WordPress that you can see. And the reason I put that comparison there is because what we're seeing in both of these products over the past decade, in fact, is a development of the platform in the form of APIs. In SharePoint, the APIs were introduced back in SharePoint 2010 with the CSOM model. And then on to 2013, there was we started to see REST calls through SharePoint as well. And then from a client-side perspective on the SharePoint platform, and this came around in 2017, we saw SharePoint Framework being introduced as a UI developed, client-side friendly UI development platform. So where before this client-side UI platform was enabled through SharePoint Framework, we saw we had to deploy code to the server. That code could influence or slow down that server environment. And indeed, I worked on any number of projects where we were trying to optimize and ensure that that code did not affect the server environment in ways that it shouldn't. But with the advent of SharePoint Framework as a client-side user interface development platform, we saw a shift in the way that we can implement customizations that puts the burden on the web browser. And that's a good thing. That means we can shift the processing power required to get our custom user interface or our custom experience out there. We can shift that down to the browser. These are just two examples. We see it in other platforms. The Power Platform is a great example as well. There's a rich UI experience that they started from the beginning of Power Platform that offers a very client-side centric, and it means that Microsoft did not have to process as much on the server side in order to get the user experience that they're looking for. And as a parallel, WordPress. We saw back in 2013 in version 3.5 the advent of an XML RPC API. That started to introduce ways for us to query WordPress content, much the same way that the APIs that were introduced in SharePoint 2010 allowed us to query data in the SharePoint environment. Same goes for WordPress as well. And more recently in WordPress, what's called the Gutenberg project that started in 2018 has enabled a client-side UI deployment framework that improves the user experience and again removes that need to deploy code directly to your servers and have it run on the servers to provide a rich user experience. So I'd like to, I guess some of these concepts have already been mentioned a bit, but I just wanted to be clear on some of the, I guess the layers that we can start to refer to when we think about maximizing our custom developed code for cloud efficiency. So what I've got here is a list of the different layers that exist, or the concepts of these different layers that exist to really sort of focus the developer's mind on what it is that they want to achieve and how best to design it for a cloud-based web app. And the first one of that is, of course, the user interface. So the user interface in modern web development capability, to be able to design your user interface without the need to concern yourself with what HTML is sent out to your users is a good thing. There's a lot of rich JavaScript libraries. There's a great ecosystem of different libraries and frameworks on the client side that can be deployed to your web browsers with consistent capability, right? Some of those libraries or frameworks might refer to as React is one of them, Angular is another, Vue.js, a number of frameworks that sort of sit and make it very easy for developers to start developing the user experience that they want. They're not so much worried now about the structure of their HTML. They're more worried about the interaction of a user and how, through these frameworks anyway, how to optimize that user interaction. So on the user interface level, we want to be sure that we're doing as much as we can in the web browser. In order to do that, though, we still need access to data. We need to, for a web app to be effective, to do anything meaningful, we need to be able to access data that's shared amongst different users across a business process or what have you. And so the data access layer is important. So when a web browser has a great application, it needs to then start requesting the data it needs through a data access layer. That's an important part of this, to ensure that, so we've got a user interface that's in place. We want to make sure those data access requests are as quick and efficient as possible. And the way to do that in the Azure sense is to implement Azure functions in a way that efficiently responds to those queries and can provide the data to the user interface as necessary. We should also think about data storage. So in a cloud-based world, a cloud-oriented world, we're talking about worldwide distributed systems. Azure is a great platform to do that, where I can say I want to deploy 5 instances of this app in different locations around the world. But I want the data that those APIs are serving to be as close to the user as possible. So we need to start thinking about how we store that data and how to distribute that data so that it is as close as possible to the user that's requesting it, but also to synchronize it as quickly and as efficiently as possible across those multiple locations. One way to think about it is typically for these types of apps that would be deployed through static web apps, is that you're more likely to be reading data than you are to be updating data. So in a cloud-oriented world, you want to think about designing your data storage to reflect a bias towards read operations to make them super quick and super efficient over the processing of updates to that data. If you think about it, the number of read requests over a typical app lifecycle might be, you might have 100 read requests for every one update request. And that really sort of focuses the mind on, if you're paying for on a per consumption basis, maybe a per gigabyte second basis, you really want to make sure that second of processing power is utilized as efficiently as possible. So you want to design your data store to not require a whole bunch of manipulation at the time of reading, and therefore to design that effectively. And finally, of course, authentication is important. Authentication is, if you want any usable solution that maybe it might be a content management solution, it needs to be updatable. You need to have authentication in front of it. And of course, in the Azure space, Azure Active Directory is a great authentication mechanism. We want to use standards in authentication. So OAuth 2 is a great series of protocols that enable authentication for many different cloud-based scenarios. In particular, for this scenario of having client and API access, we would typically look at a what's called a implicit flow approach to authentication. So we provide a token, security token, down to the browser in a secure manner that's not exposing any private keys or anything. That implicit flow approach is one of the better ways to provide that security token in a way that can be reused multiple times. The reason why we want to look at all these tiers of the application is to focus on latency or response time. And when we focus on latency and response time, we're actually looking at the millisecond level of response time. So when a UI is first downloaded to the web browser, we want to look at the number of network requests required to give the user that user interface, and we want to make that as efficient as possible. And when it comes to that, there's a number of different ways to consider that, and I'll look at that in a bit more detail in a later slide. Same goes for data access. So when I'm performing those API requests, I want those API requests to be as quick as possible. I want to give the user the confidence in the application that I'm giving to them through very efficient response times or latency. Now, why is latency important? Well, Nielsen Norman, they're a research group that are well renowned for their research into user experience, and they do put some sort of very high level view of how a user responds to different amounts of time required to fulfill a request. So when you click on a button in your web app, you can see there they've done a lot of research and concluded, describes what happens if a different response time is achieved. So when it's 0.1 of a second response time, the user feels that the outcome of that interaction was actually caused by themselves, right? It was actually, they are in full control of that interaction. Similar when it gets to 1 second response time, when they click on an operation, when they click on a button, the user still feels like they've kept their flow of thought in a seamless manner, but they still feel in control. So within the 0 to 1 second mark, that's a really good response time when it comes to displaying your web app, when it comes to responding to requests for operations or whatever in your web app. Then we move to the 10-second mark. Anything between 1 and 10 seconds, it does keep the user's attention, but they feel that they are at the mercy of their computer, and they start to wish it were faster. So we start to see a sort of a disconnect with the app, and that's not a good thing for a seamless user experience. So we want to be sure when we're thinking about response time and latency of our web apps that we do try to keep the latency as low as possible, and definitely not anything longer than 10 seconds, because the user starts to think about other things. When they click on a button and it takes more than 10 seconds, they'll start to think, oh, what is, do I want a cup of tea right now? Or, is there something wrong with my computer? Or, they start to think of other things. They're not focused on the task at hand that your app is providing. So that's good context. When we start to look at how to reduce response time and latency, there are a number of different ways to do that for each of the layers of our app. So when it comes to the user interface, a concept of bundling your assets, your JavaScript and CSS and image assets into as small number of delivered assets as possible is one element to that. And bundling in most modern web development techniques, there is a process of being able to say, okay, I might as a developer choose a number of different libraries, React for my framework, Bootstrap for my user interface elements, my buttons and so forth. There might be a font library that I want to, or an icons library that I want to introduce. A whole bunch of different libraries that you might want to introduce to your app to make that app as rich and fully functional as possible. The process of bundling ensures that all of those libraries, whereas if you might request 5 different libraries, you actually turn that into one single bundle. And what that means is when the web browser requests the page, we're only performing one web request for all those libraries that are bundled up instead of 5 or 10. And you can imagine multiplying that by the number of users, that can have a real impact on what your hosting needs to be able to fulfill. But it also means a quicker turnaround time, and it might be in the milliseconds range, but for every single request that's made, just reducing that down as much as you can truly makes a difference to the user experience and what they see at in their browser. The other concept to consider for the user interface and getting those JavaScript assets out is to be delivering via a CDN. So a CDN, Content Delivery Network, means that those assets, those JavaScript, CSS, image library, assets, they are all as close to the user as possible. And a number of CDN providers now, worldwide footprint. Microsoft in Azure, we have the option of 3 CDN providers to choose from: Microsoft CDN, Akamai, and Verizon. And those CDNs have an existing infrastructure that places that content as close to your users worldwide as possible. So if I make a request for a JavaScript bundle that is from my computer that is enabled through a CDN, I may only go to a data center that's located in my city to get that request. It doesn't necessarily come from the source location because it's been cached by the CDN really worldwide. On the data access side, so what we want to do to ensure response time and latency is reduced is to use really efficient server-side runtimes. What that means in the context of Azure is to either use a serverless approach in the form of Azure Functions, or you can, if you've got a very bespoke application architecture, you might want to containerize that in the form of a Docker image or that sort of thing. But doing so either with serverless Azure Functions or through a containerized Docker image, you want to distribute that app, that API, as far as you need to. What I mean by that, of course, is, again, if I'm in Melbourne and I am requesting data, I want to hit an endpoint that is as close to me as possible with as low latency to get that information in the form of milliseconds, we're talking here, as possible. If I make a request to a US-based service from my computer here in Melbourne, Australia, I immediately get a 200 millisecond roughly response time just from the time it takes for light to travel through the optic fiber cables to get to that data center in the US. If I can have a more localized version of that API, and Microsoft's Azure platform offers locations in every major continent, and Australia is a great example. There's a data center in Sydney and in Melbourne. I believe there's a Canberra location as well. So we've got this consistent platform, worldwide platform, that I can just say, okay, here's my Azure Function app, deploy it to X number of locations. And then I can direct people to that Azure Function app based on what their location is. And that's really powerful. It means that I can really reduce the response time down, the latency required to get there. Data storage. So I talked a bit before about designing for read, not so much for write. You also want to make sure that data storage is distributed. So the time it takes to return that data or to query that data by the API needs to be reduced down. And you don't want that API to then cross to other continents to get that data to then come back again. And there's a bunch of distributed database solutions available through Azure. Cosmos DB comes to mind, table storage, that sort of thing. We can always look at ways of replicating that data and having turnkey solutions that just put the data as close as possible to the users that are accessing your site.
Before you, Mark, continue, if you go previous slide, just a question for you. Which one of you are from the Nielsen Norman group research? Are you on 0.1 or less, or how do you see it? And the same question to the audience who are still awake. Feel free to chat. Which one are you? When are you satisfied? So that are you on a 10 seconds? Because to me, at least, 10 seconds is insanely long time.
Yes, indeed. I would definitely put the threshold for modern web-based applications to be definitely from the 0 to 1 seconds mark. There's a bunch of research around what the optimal time is that's response time for modern web apps. I've seen in different projects that I've worked on, requirements being defined to say that response time must be within 3 seconds, for example. But there's varying factors to measure that, particularly for modern web apps, and you see it in SharePoint Online today, and particularly the modern authoring experience in SharePoint Online. The concept of partial page loads changes that paradigm. So instead of a full page taking between 0 and 3 seconds, you want to measure the time it takes for that navigation to go to that other page. Because it's only some of the pages loading, you actually might want to reduce the threshold that response time is required to be fulfilled in. So it really does depend on the app as to what the optimal is. but I'd definitely say the threshold for me would be anything more than 3 seconds, and I'm starting to consider what needs to change in my app to make it more efficient. And the 0.1 second to 1 second. That's, I guess, the what you might consider to be the optimal standard for any modern experience.
Okay, cool. Thank you.
Cool. So next slide. Let's do that. Okay. So to implement a solution for that adheres to these concepts that I've talked about so far, I referred to it in the beginning of the session. The M365 May event. We ran out of Australia here a month-long event. A number of the speakers you've seen in Valo Fest actually attended and put on sessions for M365 May. And the challenge for M365 May was that instead of it being an in-person event, we had to bring everyone online. And we're starting to see more and more of this. Obviously, Valo Fest is another example of that, where you're attending this session online. So where traditionally such an event would use some tools that allow speaker coordination, for example, they allow people to nominate themselves as speakers and to then join a session and turn up at a physical location, I should say. The move online means that we need to start to think about potentially a global audience. Again, Valo Fest is a really good example of this. And we need to think about ways to direct people to the right place. So for M365 May, we built on top of an existing content management system and a third-party tool called Sessionize. We built a capability in Azure that very closely reflects the architecture that Azure Static Web Apps offers. And I guess the key point here is to get to that, we required a vast number of Azure service offerings. So for the user interface, for example, we had to deploy a Azure Static site, and that had JavaScript and TypeScript, custom developed code deployed to it. Then for data storage and static content, we had to create an Azure storage account, and we had to provision an Azure CDN to ensure that it was cloud aware and available for all users in an as efficient time as possible. For the data access layer, we deployed Azure Functions with C# code deployed to it, and the Microsoft Authentication Library for the management of that data. For authentication, we had Azure Active Directory in there, and of course for deploying of code, if there's any developers in the room, Azure DevOps was the chosen code repo provider for maintaining that code and to action the requests to provision changes to that code out to the environment for the CI/CD tool chain, if you will. We also had to do some manual configuration there to offer a test environment versus a production environment. So that was again another set of custom configuration that we needed to action in order to get there. And in order to distribute that API so that the requests for data to facilitate M365 May were as close to the user as possible, we had to deploy 5 Azure Function Services, and we put in front of that Azure Traffic Manager. So all of these components made for quite a complex, when you think about it, complex solution that is over time could be difficult to maintain. We're lucky in the sense of it being a month-long event, so the lifetime of this particular event these particular services. I mean, they're still running today, but we're not considering the longevity to be beyond a year, I guess, of use. So if you think about it from an administrator's point of view, having this number of services to think about and to worry about is quite a complex thing. And perhaps if we get time towards the end, I'll actually show you what that looks like in the Azure portal. If you're not familiar with Azure portal, I'll show you these resources and just to see the complexity of all of this in comparison to static web apps. So what does static web apps in Azure, what does it give you? Well, it gives you, and these are the sort of the high level sales pitch from Microsoft. If you go to any of the public pages around it, it gives you dynamic scaling for Azure functions. So that concept of having to deploy 5 different Azure function services for M365 May, that goes away. All we do is deploy one single service in Azure, and Traffic Manager is built into that, as is the distributed code or the code distribution to those different services worldwide. That's all facilitated by a single service offering in static web apps. Static content. So where in a traditional sense we deployed a single static site with a CDN around it, that's actually all part of that same service as well. So static web apps, you deploy a site, it's there, it's globally distributed. We don't need to worry about the distributed aspects of the service configuration. We also get turnkey CI/CD tool chain with GitHub. So from the outset, and I'm sure over time this will develop, and there'll be other DevOps providers, including Azure DevOps, tool chains capable. But from the preview release that we had announced in MS Build in May, the CI/CD tool chain is built into GitHub and is a very seamless experience. You provision the Azure Static Web Apps service, and it's almost like a next configuration. Connect it to your GitHub repository. Your developers deployed that code to that repository, and it just works. It just picks up the code and puts the hooks in place to ensure that updates to the code will be deployed ongoing. And what you also get with static web apps is turnkey OAuth with Azure Active Directory and a bunch of other auth providers, Facebook, Twitter, Google, and GitHub as well. So if you want to target users that are already Facebook users and you don't want to bother with your own authentication mechanism, then you can implement that very quickly, again with a couple of clicks, in fact, with Azure Static Web Apps. It is preview at the moment, so the approach they take is to offer invitation links to enable that initial interaction with your app, but it's very very quick and easy to do, and you barely need to even configure anything. Whereas before, you might need it. Well, you did need to deploy in Azure Active Directory an app registration, and you need to set up the security configuration to ensure that the right tokens were made available to your app and so forth. So again, this is a really great turnkey solution that provides a globally available and scalable solution off the bat. And just as a bit of a interesting point, I've got there on the screen, hopefully you can see it, a graph. This is the response times that Azure Static Web Apps that I deployed. I just deployed like a quick Hello World app, and even though I actually deployed this app to it's the Asia East region, which I believe is located in Hong Kong. We saw the response times, and these are millisecond metrics, right? We can see, for example, the response time from Amsterdam for the whole page to load from start to finish was 300 and just a little bit above 380 milliseconds. And that's interesting because my deployed Azure Static Web App was to the Hong Kong region. It probably takes more than that amount of time to communicate with Hong Kong from Amsterdam. And that's because there is a local version of the static web app available in a European region straight off the bat. I didn't need to configure anything. I didn't need to create my own Azure function service in those other regions. It just worked, and that's because Azure Traffic Manager is sitting in front of it and directing users to their closest endpoint. Ironically, the graph shows that Melbourne, which is where I'm located, is actually the slowest, and I'm not quite sure why that is. It's probably because our closest endpoint would have been Hong Kong, and perhaps that's just the time it takes to travel. I could also mention our internet infrastructure here in Australia, through the words of NBN, might have caused some of that slowdown as well. I'm not really sure. I don't want to start pointing fingers, but it's just interesting that here in Australia, because there's no endpoint built into Azure Static Web Apps today, and it's in preview, so they haven't released it to all regions yet. Perhaps that's why there's a slow response time there in the requests made from Melbourne. Cool. So I guess from that point, what I might do is just talk about the benefits. So, and I know we're running out of time, so I'll keep this brief. When compared to manual deployment, creation of cloud-based web app through all the Azure services that you need to deploy in the traditional sense, some of the benefits of a static web app, not only the maintenance and administration of these services, but from a deployment point of view, I don't need to worry about client-side routes, and that's important because when I create my app, I might have a request made to the sitename.com/customers or /products or whatever. That /products is what's referred to as a route. In the traditional CDN sense, I can't actually define those custom routes and redirect them. Whereas in static web apps, I can. And that's actually a really important thing for web developers to consider. I don't need to think about CORS configuration. Everything in the Azure Static Web App is delivered through a consistent host name, and CORS configuration is if for anyone who's not aware, if you request a piece of data from a different host name to the current page that you're browsing, that's when CORS kicks in, and you need to do some special configuration on the server side to ensure that those requests are fulfilled and not blocked by the browser. And that can be a real pain, especially when you've got multiple host names in the mix with multiple sources of data or static content being delivered through CDNs or whatever. This static web app simplifies that no end. It actually just takes all that complexity away because it's all one host name. We have staging environments.
A quick question there. Sorry. Yeah. You're a dev. You want to talk CORS, and you don't want to talk cost. How about cost configuration? How much will this cost? Cost?
That is a good question. I mean, there's no information so far from Microsoft on the cost of Azure static web apps at this stage. It's free in its current preview form. So, and of course, Microsoft are not advising anyone to, excuse me, to perform any production workloads in its current preview form. But if we look at the example implementation of a similar architecture in Azure Portal, so this is the M365 May architecture. We have, I'll just go back to the home. If you're familiar with Azure Portal, this is the resource group for M365 May, and you can see here the number of services that we've had to deploy are quite high. But for each of these services to be running, and they're of course running as a consumption-based model, I'll see if I can bring up the pricing for this. Over the course of roughly a month, or we're towards the end of the month now, so hopefully this comes up. You can see there it's well within the $25 to $30 mark to get, and this is in Australian dollars as well, to fulfill these this capability over the course of a month. And actually, when you drill down to that, the majority of that that is a consumption of bandwidth as opposed to the services themselves. So this other section here is the bandwidth costs associated to it. So at this stage, we don't have any information about what the pricing structure will look like, but I wouldn't expect it to be much more than this in sort of relative terms. And we are talking about a consumption model as well. So we're talking about hopefully it would be tiered, or it would be on a per request basis, or on a maybe for the Azure function side of things, it might be per gigabyte second. That sort of realm of cost.
Nice. So if I give you 2 minutes to wrap up, you had still a couple of points, and then Cameron can take the stage. Okay.
Yeah, definitely. Yeah, no worries. I mean, I guess it speaks for itself. If you do have any other questions that you'd like to ask, maybe now's a good time to do that. Of course, Cameron Dwyer is up next. He will be talking about building apps super fast using the Microsoft Graph toolkit. It's sure to be a hit. I think it's timely given the invigorated capabilities that we're now seeing in Microsoft Graph. So I look forward to hanging around and seeing that session by Cameron. But any questions, feel free to ask them.
Cool. Thank you, Mark. I have immediately one question, which is kind of related to both of you. So that if I understand correctly, with static web apps, I could create an application which would load fast to the client, and then you talk with the Graph API. Then you wouldn't need to use Azure Functions to perform the API requests. If you can authenticate to Microsoft Graph, then there's no reason why you wouldn't be able to communicate with that. I mean, there's all sorts of design options available, architectural options available, whether Azure Functions might perform those graph queries on behalf of the user, or the user itself in the browser might perform those directly against Microsoft Graph. Again, it's about what works for your users, what authentication is required, and how much time how much processing consumption you're going to expect on your Azure Functions layer to keep that minimized down to the lowest level. But definitely Graph API integration would be very easy to do in this application architecture. Okay, fantastic. Thank you, Mark, so much. And then next, Cameron will tell us how to do the Graph API consumption perspective. So looking forward to hear that.